Let's take a look at doing this nice limit as x approaches 0 of the absolute value of 2x minus 1 minus 2x plus 1 over x. So first of all, direct substitution will fail because that would give us 2 times 0 minus 1 in absolute value minus 2 times 0 plus 1 in absolute value over 0. So that would give you then, now look, here you're going to have negative 1 in absolute value minus, here it's going to be positive 1 in absolute value over 0. Because of this negative, it's going to be 0 over 0. So direct sub fails, so you try something else. So I'm going to understand the expressions in the numerator, like this one and this one individually first. So we have here 2x minus 1 in absolute value. That's equivalent to writing the absolute value of 2 times x minus 1 half. Yeah, because 2 times x is 2x, and 2 times negative 1 half is negative 1. Okay, why is this useful? Because then I can check things around here. So if I'm going to mark 1 half, why am I marking a half? That's coming from right here, okay? Right here, okay. Now after that, this is like 0 here, and let's say this is 1. You want to check and see what the signs are. Now remember that we're doing the limit with respect to limit as x is going to what? To 0. So you very likely want to focus like on this side of things where the 0 is located. We want to see what happens to this expression there. Okay, so I'm going to plug in 0 for example, so I will have 2 times 0 minus 1 half, or you can use the original, it makes no difference, just use one of them. Now here, don't even worry about the absolute value, because we're trying to figure out how to adjust this expression based on what happens here. So that would be with 0 present, 2 times negative 1 half, so cancel, you get negative 1. To take the absolute value, therefore, you would have to here, take the absolute value, you would have to multiply by a negative 1 on the outside, because then that would give you the negative 1 multiplied by an additional negative here, like that. To take the absolute value, you would have negative of negative 1, which would be positive 1, okay? So that means you can do 2x minus 1, the original expression, and just multiply by this negative to take its absolute value in this range where 0 is located, which is what we need. So that's one aspect. Now we look at the next one here. 2x plus 1, and again, you gotta understand, so this would be 2 times, for example, x plus a half, like that. So I'm factoring 2y, because then this reveals that negative 1 half, not positive 1 half, is the root. So you're gonna mark negative 1 half here. And again, we want to really understand what's happening around 0, because our limit is going, x is going to 0. So I would use, for example, 2 times 0 plus 1 half. So I'm plugging into this expression, or this one, makes no difference. But the point is you're going to have 2 times a half, right, which is 1. Now notice this is already positive, which is what we want when we talk about taking absolute values. So that means we can just use the expression, the original 2x plus 1, with no bars. Just use the original expression, 2x plus 1. Here we will use negative 2x minus 1. So now we can recreate our limit. So this is going to be the limit as x goes to 0. And I will say here negative of 2x minus 1 minus 2x plus 1, so I'm dropping the bars because I've analyzed each expression carefully, over x. And now the limit can be done in a straightforward fashion. The limit as x goes to 0 of negative 2x minus 1 minus 2x minus 1, and this is a plus over x. Okay, and then let's see, these would cancel here, so what's left is the limit as x goes to 0 of these two combined, so negative 4x over x. Of course the x's will cancel. In fact, all that remains is what? Negative 4. If this is helpful and you enjoy and you like these types of videos,